Hey boss Divya, what you see here is nothing but an ultrasonic sensor SR04, and it is used for a distance measurement. For the project that require a distance measurement, this must be a good choice. It works by emitting high frequency sound wave and measuring the time it takes for the echo to return back to the receiver. This allows it to determine the distance to an object within its range. The key component of the SR04 sensor is that you see here we have what is named R, that is a receiver. It receives an echo that bounces back after hitting the obstacle. Then here we have what is named T, that is a transmitter that transmits an ultrasonic sound which later on hit the obstacle and then return to the receiver as an echo. The pin out of it, you see it have 4 pins. The one which is named as VCC, that's a positive supply DC voltage. Then you have the other which is a GND, that is a ground. And the voltage to supply this can go beyond 5 voltage. Then you have a trigger echo pins. Trigger is for sending a pulse that will initiate the start of ultrasonic wave. It means it will enable the transmitter, this one, to transmit an ultrasonic sound. And then there we have an echo, and that's a pin where it will be able to work with the receiver. It will enable the module to work with the receiver and then send the received echo in the form of electrical pulse to microcontroller. Then in this video we are going to work with the distance measurement, and then the component we will need is the sensor itself. Then you will need arduino nano, and then you will be using a 16:2 LCD display with I2C module. If you want to know more about this, there is a link shared. Look at the link shared in the corner of this video. You can go directly and know more about this. Jumping right on the way of testing the sensor, you see here you have the circuit setup that is made by display, and here we will be reading the distance measured by this sensor. And then you have the Arduino Nano. Then we have a USB here that will be used to program and power the system. It means to program and power our circuit configuration. Then right here you see that we have the module connected. We have the trigger and the echo pin connected to D12 and D11 of Arduino Nano. Then we have the 5 volts power supply. You see this red wire. This red wire goes straight to 5 volts Arduino Nano pin, and then the yellow wire goes to ground. And then this display must be also connected to the power. You see that it is connected parallel to the supply of this module, this sensor module. And then we have the serial clock and serial data pin of serial clock and serial data. Then you see the clock, and the data pin of the LCD display connected to pin A4 and A5 of Arduino. The circuit is shared down in the description. You can download the circuit on the link shared in the description. So let's go connect and test if our sensor has accuracy. So now there we have our circuit connected to the computer, means it is powered. I already downloaded the codes to the module Arduino Nano. And then here we have the obstacle, and then read there we have a 20 centimeter. When I try to pull the obstacle close to the sensor, you see that the distance goes slowly reducing, and then there we remain with the 8 centimeter. Then you see when I pull back the obstacle, the distance changes. We can confirm that our module sensor SR04 ultrasonic sensor can work correctly in distance measuring and the object detection and ranging. Let me try to bring a tape measure to see if it is accurate. When I put a tape measure there, see there with the tape measure, I am reading 15, and then when you go there to the display, you will see that I'm having a digital 15 centimeter. When I move close to 10, see that there I have a 10 centimeter. See that our ultrasonic sensor module is working perfectly. So some people say that except if there is a change in humidity or temperature of the environment, you can confirm that this sensor works accurately and correctly. So let's try jump to the code to try to explain a bit how the code works. Now here is the code. You see that we start by including your library wire.h. We include also the library for interfacing the LCD with I2C. Then here there is an object declared. Then we declare here the pins on which our sensor is connected, the variable distance in which the calculated distance will be stored. Here we initialize the LCD display. We start the LCD display. You can comment this because it is double down. Then we turn on the display. Then this LCD.set cursor, it's like to set the position on which this word will start writing. In the void setup, I have also to configure the trigger pin. You see the trigger pin is output because it will send the pulse to the sensor trigger pin. Then you have the input pin echo of the microcontroller because it will be the output of the sensor. Means the sensor will send pulse in ultrasonic pulse to the transmitting part. Then the echo will return back to the sensor. Then the sensor calculates that echo, and then the data obtained will be sent to the microcontroller via the echo pin, which is pin number 11. Then the void loop, you see that we generate the frequency, means going low and high of the trigger pin. Then here we have a delay. Here we generate a trigger signal of 10 microseconds of delay because it is what is required to generate an ultrasonic sound to be sent in the air so that you can find an obstacle. This line is for reading the echo, means the time taken for the echo to return back to the receiver after hitting an obstacle. And then this formula will help us to get the distance. You take the duration, then you multiply by 0.034, then you divide by 2 to get the distance required. The calculated result will be printed. Let me try to plug a bit. You see that there you have a title, which is a distance measured, and then you print out the distance. Guys, thank you for watching. If you love this video, please hit subscribe and leave a comment down how you want this channel to be working. Leave a comment with also an advice. Thank you for watching. I hope to see you guys in the next video. Ciao, bye.